So we're going to be talking about how we can do this, creating delightful UI, and keeping performance in mind. My name's Mike Hartington. I work at a company called Ionic. You can find me everywhere online as M. Hartington. We're going to talk about performance first, because performance is one of those subject matters that leads to a lot of confusion for several reasons. Performance as an idea or as a concept for development can mean several different things to several different people. You could be talking about the load performance of your website. How much are you sending over the network? How fast does it parse once it's on the client? How quickly are you updating the UI in parts of your app, right? There's no limit to how many different acronyms developers have created. Largest contentful paint, time to interactive, all these terms all define what I think is the front end of the front end for performance, right? You're not necessarily thinking about JavaScript parse time and how quickly your code is getting executed in the browser. That's a framework problem. That's a tooling problem that you should not have to manage. And if you do, I'm sorry for you. We're talking about UI performance, right? Things that are in our control and things that we work on and our code impacts. How fast are we updating bits of our UI? If you're in a shopping cart or an e-commerce site, how quickly are you hitting add to cart and seeing that UI update in the top corner? Are you adding animations to your app? Are you doing that in a way that is performant? 60 frames per second? Are you doing all of this stuff and then having some background processing happen? Maybe you're calculating shipping and you want to just crunch some numbers in the background without blocking the rest of your site. How can we do that with keeping the UX and performance in mind? Let's start off by just stating what should be pretty obvious. This stuff is really hard to do. My first animation looked great on my MacBook, and I loaded it up on my phone. It was super janky, and that is a technical term, meaning it just kind of just janks around in your device and shows obvious signs of just a performance bottleneck. And we can avoid that by just being a little bit smarter about how we approach all of these problems. So specifically with my work at Ionic, we deal with a lot of mobile-specific situations, which tend to lead to this phrase: you could have a really good website and a really good progressive web app, but if one little thing feels off, the phrase I always hear is, "it doesn't feel native to me," which I think is a really good indicator of the positives and also the negatives of native apps. Positives, users now have a really good inclination of what is performant and what is terrible. Your average user is actually pretty smart about this stuff, and they can smell out crappy UI really quickly. On the other hand, this makes our jobs a lot easier because native kind of has some of these features baked in for free, and they don't necessarily need to worry about the underlying stuff. They just have a function for animation, and it handles all the setup, the teardown, doing it in a way that is fast and efficient. All they need to do is just create the function. So the best way to kind of figure out how they do this is to just imitate native and to look at what native is doing and try to understand how you can implement that in the web. For instance, for me, I use Apple Music. I'm probably one of the only people who use Apple Music. Spotify, yeah, okay.
Hey, Apple Music.
Yeah, Apple Music gang, show up. For me, what really kind of showed this was Apple Music as an app is not that complex of an app. All playing audio and streaming audio aside, the UI for this is pretty good. And it shows off those 3 key points here where we have a state change as you play and pause. There's a shadow effect there, there's a scaling effect. You can cycle through music and update the background color without blocking anything else. And you have this really nice UI change where as you toggle the queue of songs, that animation is happening, and it's quite complex because there's a lot of smaller nuanced interactions in there, and how those two parts interact with one another is pretty complicated. And so I got an iPad and I was playing around with this and doing these recordings, and I had about 2.5 years of free time to go down the wormhole of just recreating Apple Music, but with web technologies. And like I said, those three features there that really make Apple Music stand out and add a lot of character to the app itself. The animating of the card as you play and pause. The animating of the cue entering and leaving the frame. And then the reactive background changes. Those are three things that if Apple Music didn't have those, it would be just a regular blah music player. So there is the nice stuff, the fun. Let's go ahead and implement this. For reference, some of the code that we're going to be looking at, I used Ionic and Angular. Big surprise there. I'm a huge Ionic and Angular fan, obviously, because I work at Ionic. But everything that we're going to look at is not specific to Ionic. There are some parts here where the implementation uses Angular code, but the same principle can be applied to Vue, React, vanilla JavaScript if that's how you want to roll. Again, I feel bad for you. So none of what we're going to look at here is specific to one tool. It is all applicable to every tool out there. So let's dive in. So that first big part is animating the right things and creating that sense of elevation by scaling the card and also having a shadow in there. And if you missed it, we'll kind of show this real focus on it. It's really subtle, but you can tell when the song is playing, there's a big shadow towards the bottom and then also towards the sides. As someone who went to school for art and learned how light works, this is actually a really good reference of how actual shadows can work, because you don't have just a one light. You have the light, and then you have the spread that creates that illusion. Now, when we go to the pause state, that shadow instantly reacts to show something being closer to the surface, and it's not just disappearing, it's also kind of translating everything into a central point. So, best way that we can think about this is we have a shadow, and we want to change that shadow as we're toggling the state in our app. And like any good developer, I went to the internet, found some code online, and copy and pasted it and threw it in my app and hope for the best. And that's not to say that that's a terrible idea. Actually, I borrowed a lot of reference material from Google Material Design. Not like a dig at them, total shout out to the elevation stuff in particular, because they give you better box shadows than you could probably create yourself, because they actually had designers work on them. The box shadows in here use complex multi-step shadows to definitely give you the better sense of elevation. And you can see it here in this in figure 1 on the bottom box. There is more depth to that shadow, but it's also not just one-dimensional where it's just down. There's a spread and everything to the side. Really good starting point. I tried to throw it in my app, and then I wanted to do a stress test on this. And you can't see it really well in here, so we're going to go over to Edge, and we're going to open this up to see how this looks. So this is the shadow that we get from just copy and pasting code from the internet. I've changed the colors to just be red because that is the best way to show it on a large screen. And while this is just doing a keyframe animation for stress testing, we can see the impact of this real easily. So if you've never opened up DevTools, you might not know that this thing exists. Show of hands, how many people know that there is this paint flashing feature in DevTools? 1, 2, 3, 4, few people? Okay. So paint flashing, it's part of the browser's layout process or rendering process where they go through and they say, anytime we need to paint a color, we go through this paint flashing or this paint process. And we can see how this is impacted by just toggling it. And we can see every part of our app that is getting repainted. And it's not specific to the shadow. This happens anytime that there is a UI change in your app. But this is going to be really interesting because, as you see, the shadow itself is not as big as the green box. So that green box is all of the areas that are getting impacted by our small, simple shadow. And again, it doesn't seem like it's that big of a deal because we're on a decently spec MacBook Pro, but we can figure out ways to test this out and simulate what would happen if we were using, say, 2-3-year-old Android device. We'll go to a 6x slowdown because assume the worst situation and then you'll be better for it. Okay, nothing really looks terrible. Let's go to performance monitoring. And let this run for a little bit. Okay, that's long enough. My MacBook Pro is already starting to warm up a little bit. What we see here is that we now have something around 60 style recalculations and repaints every second from this one little shadow. We're also hitting our CPU up to 30%, which doesn't seem terrible, again, because we are in an emulated 6x slowdown. We're still running on a pretty well-spec CPU. Your mobile phone is not going to have that same capabilities. It could be slower, and it's also going to have a lot less cores, so that usage is going to skyrocket. So let's go back to the slides real quick. Shadows are terrible for performance, and this is really, really important. If you are using box shadows in your app, probably don't. Please, if you take anything away from this talk, is that I hate box shadows, and you should too. They're terrible for performance because of that painting process. Because every time that you have a shadow in your app, not only are you calculating the color from the shadow, you are calculating the color that the shadow affects in the background. So if you have complex shadows, you are doing a multi-step calculation for how those colors are going to need to look. Throw in an animation in there, and now you are having animation cycle happening. You are impacting every affected area, which is why we can see the browser scaling that box and affecting other parts of this. Now, the CPU usage, I want to harp on that a little bit because that has a direct impact on your user's battery. In fact, this was at 100%, maybe 95, and we're already now to 85. Granted, I'm running Keynote and everything, but there is a distinct effect here, and if we can get a little close, I don't know if it's coming through, but the fan is actually on my laptop right now. So you can see the actual impact of this. Now, I'm going to be smart this time, and I'm going to not have the slowdown enabled and reload real quick. Now, what we have, or what we can do to solve this is just rethink how shadows work. Anyone do some work in Photoshop before? Few people? So in Photoshop, how would you add a shadow to something that, you have a solid masked image? How would you add like a more realistic shadow than just adding filter drop shadow? You would take another layer, start to build that out by using the original as a reference, and start to do some spreads and do some work to make it seem like it's a real shadow by using another reference. We're going to take that same approach here. So here in the original implementation, and let's just bump that up one more time, we can see we have our animation. Every 3 seconds, we're just going to scale between 0 and 100 to 50, and we're going to use this box shadow. This is the complex box shadow from Material Design. Really good in most cases. We are going to get rid of it because this box shadow is actually terrible. Instead, we're going to make use of this pseudo element. Now, pseudo element basically means nothing. There are some caveats to that. If you, unfortunate timing, you could have gone seen Homer's accessibility talk. I'm sure there are some accessibility concerns here, but for the most part, we have now a free div where we can style it, scale it, do whatever we want with it, set a background color to be that same red, add a blur, and then we're going to use Scale 3D and start to promote this pseudo element to its own layer. Now, layer is a very fancy term by saying it's going to get rendered in a different manner than, say, a box shadow would. Now, in our animation, instead of changing the actual shadow values, we're going to just scale it and do some translates to mimic that look of light kind of being affected in here. So with this save, let's let that run. The app is already updated. And here we go. I don't know why the scaling effect looks terrible. That's not great. But let's just kind of zoom in a little bit. You can see the scale there. In fact, let's go ahead and make this more obvious. This could backfire. This is not planned right now. So let's see how well this works. I know why. Pay no attention to what I'm actually doing right here. A rogue overflow hidden. There we go. All right, super obvious that we have a shadow now, right? Let's open up our DevTools. Let's go back to the rendering and enable paint flashing. Already we're in a better situation by just having that because our pseudo element is not impacting everything else inside of our app. We're not infecting the other areas. It still can have opacity. Like we can still come back to this, and if we want to do, instead of a full color, we'll do 0.8 seems like a solid opacity level. We still have opacity. We're still doing stuff behind there, but we're still not causing any repaints. And if we go to our performance monitoring, actually, let's go back to the performance and hit that 6x slowdown. We can see our CPU usage is much less than it was before. And we don't have any style recalcs, repaints. We don't have anything going on in here that is negatively impacting our app. For lower end devices, this will save their battery. I'm sure there's a calculation that you could do in here, but I don't actually do math. I just make pretty awesome box shadow animations. But this can impact the actual performance of your users' devices, and everyone should be happy about that. Now, we're going to go back to performance monitoring and not do a 6x slowdown. So all that together, we can sum it up real quick, and just in case demos failed, we have our component, we have our original implementation, we're doing keyframes and box shadows. Pretty nice, much better, because now we're being smart about how we create that shadow and how that performance is going to impact. What's even better, though, is that in our original version, we had a multi-step shadow. 3 different shadows that are getting rendered here. And pseudo element, we maybe get 1 or 2 before and after. If we're using a framework that allows us to create custom components, we can simplify this and just have all of these shadows be empty divs that are hidden away from the users. So all these shadows can have different layout and different positions that are not the same. They have one coming down, one going to the left, one going to the right, different transitions, but they're still based on the same thing. And then we can animate all of those individually to create that illusion of a more rich box shadow. So all that together, we have this implementation, which is using the multi-div approach. Still have better performance. Overall, really great. So we have to start here, though, because if we didn't tackle this and we try to do it with everything else going on, it's going to get real hairy. So we can animate the right things by just being smart about how we approach it. Don't use box shadows for animation. There used to be this really cool site called CSS Triggers, where if you tried to do any property, or it would tell you any property that would trigger a repaint, a layout shift. Google Chrome, their Chrome team took it down, unfortunately, but it does exist somewhere out there in GitHub. Definitely check it out and just look at that list. It's super valuable. So the next one is this dynamic and unknown animations, and that's that layout change. The layout change, at first, I thought was going to be super simple, right? You have one bit, translate it over. You have another bit, translate that over. Fairly simple concepts, super, super complex. Because once you have one element and you try to animate that, as soon as you add another thing to the DOM, your animations essentially are going to be off by whatever that original element is. So if you have the center, point, and you're like, all right, I'll just animate it over, and then you add the new thing, there's like, hey, no, you're now offset by your center. I almost gave up on this until I found a really great article. It's not new, and none of this concept is stuff that I created, but it's this thing called flip animations. Has anyone heard of flip animations before? One person? Another great thing that you will learn. Flip animations, like anything with web technologies, is an acronym. We have this idea of when we want to do complex animation, we're probably wanting to know the X and Y of an element, and we're going to take a snapshot. We're going to use this function called getClientBoundingRec, which I will mess up saying that again because it is a terrible function name. We get the X, Y, width, height. We get all the information about this element that we need to know in order to do our animation. And then we're going to cause a layout shift. This could be adding elements to the DOM, toggling a class on a parent container to change the full layout, whatever. We're going to do all of that. And then once that element has changed its position, we're going to get the same X and Y, width and height information again. So now we have the start and the end point. How do we figure out the stuff in between? For most stuff, we're just going to do this inversion where we take the before and after, subtract them, and now we have our travel distance. So now we can have a travel distance, and we can say, hey, element, animate from this, and we're just going to use that travel distance as our source of animation. And then when we hit play, it'll seem like that element just traveled through space as other pieces of UI are rendered at the same time. And your browser is fast enough to know how to do this, so that way there is no kind of like frame where you see the layout shift and then you see the animation. The browsers are pretty good about optimizing for this. Now, I've only ever seen examples that do like this style where you have a width and height change or a X and Y change. I've never seen anything do like a complex animation like I have to do. So this took a little bit, and we're going to look at a simplified version first, and then I will show the complex version. So starting off, we have our two elements that we want to animate, the queue and the player. We're going to grab those, and we're going to call this getRec function. If you think I can't say getClientBoundingRec, try typing it out. So I aliased it. Basically, we're just going to return the X, Y, width, and height. Now we cause our layout shift. This is just going to change the layout. The player queue, or the queue of songs that are shown on the right side, we're going to change the display to be visible, and we're going to show that. Now we can go ahead and get our last data. Now for the player, we have a pretty simple X and Y change. We're just going to do player, we're going to do the left, or the pre, and then the post, and we're going to subtract that. And then we're going to do it for the left, and we're going to do the same thing for the right, or for the top. With the width and height, we can be smart about how we do this, and we know that we're either going to be visible or not visible beforehand. And so we can simplify this by just doing a quick little comparison. So all this second function from 15 to 22 is doing is looking at the before and after and saying, hey, was I 0? Okay, return 0.8. Hey, was I 1? Return 0. A little simplified math. And then we can use this create animation function. This is from Ionic, but it's not specific to Ionic. You could use pure web animations here, and the same effect would happen. We get our element that we want to animate. This is the Q. We do a transform. We do from to and do transform, and then we do a scale 3D to translate from those original values. Then opacity, we have the opacity from either a 0 or 1, and then we go to the 2, either a 0 or 1. Pretty simple. The track is even easier because we're just doing a from transformation or from animation, and that's giving us the delta between the original, the before and after values. So all this together gives us something like this. Pretty basic. You notice that as the element leaves, we just get this flash and then the element moves over. I'll show the actual values, that way you can see how that looks. But we have the basis for a good animation process. We know that we're not actually hard coding any of this information. It's all being computed at runtime. What's even better is that we can take this same animation, add like a couple if-else, and have a different animation for when we're in portrait mode. So if you ever wanted to have complex animations that depend on your user's device orientation, you can do that as well. Now, the real animation code is much more complicated. It's 266 lines of code. Not that lines of code are anything to kind of brag about, but it took a lot of work to figure out how to do this all together. And one of the big reasons why is that leaving animation. Let's go back to Keynote real quick and go to the other one. That leaving animation really, Safari. How bold of you to assume I wanted to open you. That leaving animation is really difficult because now we have to make sure that we handle the layout before it gets set to display none. So to do that, we have to make use of some absolute positioning. Anytime I have to see absolute positioning, I assume something's going wrong, but in this case, it's actually what we need to do. So we can come in here, and we have this hook where we, in Ionic's create animation function, that allows us to set some styles before doing all the animation. So in this case, we're going to hard code the position of our element, so that way when we go through and we start to animate it, we are animating the absolute position element, and then we clear out all that absolute positioning logic afterwards when the animation is done. So we set the position, we hard code it, we do our to from or from to, whatever it's called. We do our animation, and then we clear all that stuff out, so that way we have like a little cleanup function. Now, that together gives us, let's go ahead and close that, something like this. Now, even though there's no songs being played right now, we just have an empty queue, you can still see that we have that closing animation working. And if we open up DevTools again, go to the animation controls, it's really fun, is as we play this, we can see the effects of everything that we're doing. That now playing thing, or playing next, has already been shown, and we're just controlling the transforms of a absolutely positioned element. Very fun. I'm actually very proud of that. So animations, just to remind, we were using Ionic's animations in this example. You do not need to use it, and you probably shouldn't. You could use web animations, or if you're really, really smart and you can justify it, use GreenSock. They actually have a plugin called Flip, which you set the parent container, you set an easing function and a timing, and it will do all of this for you. Actually, there's a speaker around JD who gave a talk at ViewConf about GreenSock, and ask him all about it. Also tell him that I told you to go talk to him, and I said that he did a really fantastic job. But GreenSock will go ahead and handle all this for you without you having to figure out the math part of it, because that is probably the more complicated thing. If you aren't sure how to approach and solve that problem, just go with Greenstock. Your life will be better for it. Okay, how are we on time? Doing good. So our last thing is this reactive background changes. Now I kind of cheated because I had done this before, and that's just getting the album artwork to impact another bit of color. So for reference, let's go to the next song. It becomes really obvious in this album artwork, and I really, really like it. I had done this before, and I had found some tools and libraries, but I want to make it better because it all runs basically synchronously. So there's a library out there called Color Thief. If you've never heard of Color Thief before, check it out. It's been around for at least 6-7 years. All it does is it will take an image, render it to canvas, do a bunch of comparison and of all the pixels in that canvas, and give you an estimated return value of what is the dominant color. Now, if you look at the example, there's the plate, there's some vegetables and a dipping sauce, and the dominant color is obviously the plate. It is the thing that draws your eyes most quickly, but it's not the only dominant color. You'll get a palette of colors that are first, second, third, fourth, and so on. So if you're doing something, has anyone used Android, is it Material U? The new Android flavor has a different material design where if you set a theme, your entire UI updates to it. This is how they're attempting to do it in material components. So it'll analyze that image, return that color based on sampling size, quality, what have you. I wanted to take this a step further and use a web worker to solve this because I hadn't had a good reason to learn about web workers or actually use it, and I want to see if this could be possible. So I took all of Color Thief, extracted it, added TypeScript because it was written in a time when TypeScript wasn't really a thing, and I used an Angular directive to react to when an image source changed. So let's take a look at that. And again, as I mentioned before, the same thing could be done with React, same thing could be done with Vue. This is just going to be an Angular directive for me. So Angular has this thing where you can react to when a property changes. In this case, we're going to react whenever the source property changes. We're going to do some quick little comparisons. There's a fun story in here about how Apple Music returns multiple images over 50 milliseconds with different query params at the end, but it's still the same image. Why? I have no idea. Maybe it's just Apple's way of trolling people. But I do some quick little comparisons to just say, hey, if it changes and the images are the same thing, just go ahead and ignore any new changes. So we get this get palette from URL. We'll get that image URL, and we'll actually download it and create an image object in JavaScript. And then once we have that image, we're going to go ahead and call this get palette. Now, this get palette is going to have some defaults that we provide. Basically, the number of colors we want to return. We can do 10, 5, 500. Probably don't do 500. And then we can get the quality, how much sampling of this image do we want to do. And then we're going to render that image to a canvas, get the canvas data, get the pixel count, and we're going to pass that to our web worker. The web worker is going to take all that and start to do the real work that Color Thief would do of quantizing all of that data and getting the common RGB values from it. And that's all done in the worker, which we'll check out in a second. But once the worker is done, crunching all those numbers, we'll just get this onMessage handler where we can get the data out of it. And because we're using Angular, we'll just emit that data through a custom event emitter. And then obviously we'll remove the canvas because we're good developers and we like to clean up after ourselves. So the worker for this, now let's take a look at it. And this is all Color Thief. This is not my writing. I'm not that smart. This person is. Let's just keep going. It is so much math. Basically, when we get that data sent to us, we have the pixels, the pixel count, color quality, color count, and then the quality. And then we're going to create an array of arrays where each inner array is an RGB value, or RGBA. And then we just do all that comparison, and we call this quantize. We get the palette, and then we do post message to send it back to our main thread. So all that math can run in the background. It doesn't matter how large of an image you give it. Could be a 1080p, could be a 4K image. It'll run in the background without you ever having to worry about it interfering with the rest of your app. And then when we go back to our actual app, here's the web version. You can see that as we go to the next song, automatically reacts. We're just doing we're doing a quick little transition on it to react whenever the background color changes. 300 millisecond duration, nice little Bezier curve for the easing, and it looks wonderful. So this is the part where we're going to see the final effect of this all together. There's a QR code for where that actual web app is now. You can take a look at it. There is StarTrack-ng.web.app. I'm terrible with names, so I just stole one from another app. We can take a look at it and see how this goes together. I'll leave it up for a second because I see some cameras out. While that's happening, I'm going to open the app. So here is the app, and I wanted to do light mode, but my eyes are killing me. We could go to Taylor Swift. It's not going to be as great when we don't have multiple album artworks. I just wanted a chance to highlight the Taylor Swift album. Definitely go listen to it. We're going to look up, has anyone ever seen this face before? Definitely got popular during the pandemic. Let's go ahead and play some music. So we got some music playing, right? Let's open up this. Now, I took it a little bit further and have made the background color a lot better. So you can see here we got multiple colors happening. We got a little bit more of a richer context. And we still get the smooth animation. We get the nice play, pause effect from the shadow. And then animation is super smooth. This can be on a mobile device. This can be on your powerful desktop. The animation is still going to be 60 frames. And I also had a nice little animation for when the song leaves. That's not very complicated to do, but it is fun. So we're going to let this play in the background. So we can have nice things. I wasn't kidding when I said that's something that I love to do. Core thing for me is I want to have the fun, great things that native has on the web. And it is possible. I hope that you've gotten that from me, is that this stuff is possible to do. We just got to be a little bit more clever than our first instinct. If at first someone says, add a shadow to your app, don't reach for a box shadow. In fact, there's tools out there that can analyze your CSS, and you can ban box shadow from your rule set, which please do. You can use pseudo elements or divs or basically meaningless elements to create the illusion of a shadow. Flip animations are going to be a key thing. Think about that shopping cart analogy. How would you do that transformation or the animation as the item goes to the cart? It's kind of cliche now to see, but that can be done. And web workers, in general, just try them. They're super awesome. They're like a really low effort way to do some offloading of math from your main process to another thread that can just send the data back when it's ready. So I hope you've enjoyed it. I hope you've gotten something from this. But if you have any questions, I'll take them. But otherwise, thank you. Yeah, we're done. So, questions? No. Yes? No? Maybe so? If not, we ended a little early and you get some time back. So go get some coffee, drinks. Go stop by the Ionic booth. We got t-shirts and stickers. Who doesn't love t-shirts and stickers? Thank you all.